great to be here with everybody today. I'm Jen Starr from Manager International Education Partnerships at the AEF, and I will be facilitating the rest of the day. My first job is the absolute pleasure of introducing Pam Robertson, who is a research fellow at the Assessment Research Centre at the University of Melbourne and works on projects relating to assessment, both large scale and classroom, and the use of assessment data to inform decision making. Pam is experienced in the development, validation and evaluation of assessment materials tailored for specific purposes. She also teaches courses in the areas of assessment. She's been involved in numerous projects, both within Australia and internationally, involving formative uses of assessment data, judgment-based assessment, assessment of prerequisite science and mathematics skills, and the alignment of assessment and curricula. Within her role at the University of Melbourne, Pam is also a staff member at the Assessment Curriculum and Technology Research Centre, a joint program with the University of the Philippines. Pam Robertson has previously been a teacher of maths and science and has co-authored multiple physics texts. Welcome, Pam. It's great to have you with us.
Thanks, Jen. It's great to be able to join you today. Welcome to everybody. It's lovely to be able to see some faces on the screen, but I understand for those of you who are not showing your face that there are all sorts of really legitimate reasons for that. So please don't feel as though you need to put on your camera if you don't feel comfortable with that or you're not able to. So I'm very pleased to be able to speak with you all today. The STEM education is a subject of research that's really close to my heart. You heard that I'm a former science and maths teacher, particularly in physics and mathematics, right through to year 12 in our schools. And I did that for many years before I moved to the University of Melbourne. So that's something that's been a constant theme throughout the work that I've done. And I'm very happy to be able to speak with you today and to share some of the insights. I don't know whether you've experienced this before, but if we were meeting here in Australia or at the University of Melbourne, I would begin, as is customary for us, with an acknowledgement of country that acknowledges the Indigenous owners of the land on which we're presenting and which we would be gathering if you were in a face-to-face mode, but I would still like to do it because I'm still presenting on their lands. So I would like to acknowledge the Indigenous owners of the land on which I'm presenting today, the Wurundjeri people of the Kulin Nations, and I pay my respects to elders past, present and emerging. So I thought I would start today by taking a very big picture and thinking about what's going on internationally in education at the moment. And what we see, no matter which country we're looking at pretty much, is that there are really a set of new learning ambitions that are arising. And these are arising because the world is changing. In previous times, education was about giving students mastery of content, and through content mastery came power. But things are shifting now. As we become more able to access content whenever we're ready to learn it, rather than when we have the opportunity in school, we're seeing a shift towards 21st century skills or transversal competencies or general capabilities, however you want to frame it. So we're starting to prioritise things like problem solving, communication, critical thinking, in some cases entrepreneurship. We're really starting to question what sort of skills our students need to have when they leave school. What are our ambitions for them? Now you'll see on the right of the screen, these new ambitions have led rise to a sort of a cascade of new things. With new ambitions about what students should leave school with, there are then the requirement to have new assessments. And when we have new assessments, we also have to think about new standards and new ways of credentialing those standards, new settlements, which are ways in which the community trusts and understands those new credentials, and also new metrics, which is really a whole area of research and study that needs to sit at the very base of this and support all of these new ambitions. When Kathy shared with me the ambition from your curriculum, from Dr. Combra, I looked at that and I thought, oh, that's fantastic. PNG are at the right, they're neck and neck with everybody across the world, with all the movers and shakers. And these aspirations for STEM education are really important for ensuring that your students are able to deal with the continuous rate of change that's just getting faster and faster at the moment. When I look at this description, I see a lot of things that are interesting. We're talking about the knowledge-based economy. So we do need the students to understand some content, some science and maths and engineering knowledge. But we've also got lots of other aspirations in there and ambitions. We've got them to be creators, innovators. So they're not just consumers of that knowledge. They need to be able to use it in ways where they can build new things and innovate and change. And I love the description of inventors of knowledge. Not only do they need to be able to do that, but they need to then speak to the world of business so they can commercialise their creativity and develop intellectual property rights. So these are lofty aspirations for these students, but really timely ones, because it's noting a shift away from the idea that you will be successful if you have knowledge. It's no longer that. It's you will be successful if you know how to use the knowledge that you have, and you know how to learn new things independently. So with this in mind, I'm going to use these headings down the side, new assessment, new standards, and new credentials, to frame the rest of this presentation. With the aspiration that is in your curriculum, I noticed how closely it aligned to the PISA definition of global competence. And this definition has come about because, as you know, PISA are an international organisation run out of the OECD, and they're capturing this change, this shift that's starting to emerge in nations, and they're trying to capture and express that to everybody. And I really like this diagram, so I thought that I would share it to you. It takes knowledge, or basically the old curriculum, and adds skills and attitudes and values to that. And it says, but we're not even thinking about those in isolation. They combine to build people's competence, and that their competence in turn leads them to be able to act. And I thought that this diagram really captured the nature of what that statement, that aspirational statement at the beginning of your curriculum was. So let's look at how we can start to actually enact things that will lead us to giving students these outcomes that we aspire to. I wanted to start with credentialing, and credentialing is probably something that sits more broadly than the work of STEM curriculum writers, but is something that you need to be thinking about. As different groups around the world are thinking and struggling with how do we capture and express knowledge, it's no longer sufficient to just say, this person has finished school, or this person has achieved this grade or this mark in this particular subject in their final examinations, or something like that. It's not enough to capture this really rich idea of competence. And because of that, many different groups independently have generated what are being called collectively learner profiles. They all look a bit different, but lots of them have this kind of feature. If you notice over here, I know that it's a little small, but we're talking about the disciplines. So this is the knowledge section. We also might have some general capabilities, or 21st century skills, or transversal competencies, or whatever terminology you want to use for them, that might be assessed even across different traditional subjects or learning areas. Some of the learning profiles even have this section down here, which is know-how. And the know-how section is, can they apply this and use it for action? So that's the last part of that PISA diagram. If we think about this with STEM education, the discipline is not just the amount of content that you've learned, but rather what you can do with it. So these arrows or parts that jut out in the discipline section might be about reasoning with understandings of matter or applications of physics. So it's not just physics content, it's what you can do with the content. If we go over to the general capabilities side, when I was looking at the statement of ambition in your curriculum, I could see that there was clearly critical thinking, problem solving, entrepreneurialism. There's probably some others that go there as well. The general capabilities might be broader than that, and some of them might be picked up more in other subjects than in STEM. But there are a lot of these general capabilities that are really well meshed with thinking about STEM education. When we come down to the know-how section, we might be talking about, are the students actually involved in environmental activism? Are they out there trying to do something that makes a difference in their community or their society? And that's what the learner profiles that have a know-how section in them are referring to. And so you would look at what has the student been able to achieve in those circumstances as well. The aim of the learner profiles is to give this really rich and well-rounded understanding of the learner. And these learner profiles are being driven largely by employers, because they're saying, I don't need to know that the student has passed year 12. That doesn't help me decide whether I can employ them or not. I need to know more about them. I need a richer information. And so they're driving these changes, and this is the kind of thing that they want to know. They want to know, where are the relative strengths and weaknesses? Where are the things that these students are really strong in? Where isn't it? Because when the employers go to choose them, whether it's straight out of school or after university, they're telling us that they want more nuanced information so that they can match the person to the job. Having a single bar that everybody is expected to jump over is no longer satisfactory for them. They're saying that doesn't give us the information that we need. It doesn't make your graduates employable. And so the new credentials do. However, if you're going to be able to report something like this, then a whole lot of other things need to be in place. And this is where it really starts to hit the decisions that you make as STEM curriculum writers. Let's think about the standards, because the standards are always embedded in the curriculum. And what we see is, if we want to reach these new ambitions that we have for our learners, then the curriculum and the standards that are embedded within the curriculum need to really change. On the less side, we have to have less content. There isn't enough hours in the day for the students to learn all of the content that they would have traditionally learned, plus learn all of the skills that will enable them to use that content to generate new knowledge, to create IP, to do all of those aspirations, to really make a difference in the world. So we have to reduce the amount of content, and we have to increase the focus on competencies, because they have to be explicitly included in the curriculum so that everybody is clear about what has to happen. The other change that we tend to see is that passive learning, the kind of learning where you sit and receive information, is reduced, and active learning, where you have real-world problems that you use to try and show and learn more, becomes more important, because it's only when you're requiring students to grapple with those real-world contexts that they get to develop the kind of problem solving and critical thinking, all of those other things. So there's been a real shift in what's required. Many countries have made the mistake of adding the competencies on top of everything that was already there. And that just results in an overcrowded curriculum. It's got to be such an issue that the OECD last year released a summary of research to try and help curriculum writers to address the issue of overcrowding. And I think that that's a very good document that would be something that I would highly recommend you reading. I've put a reference for it at the end of this presentation. The other thing that we see coming out of the push for the employers to have credentials is they're saying, we don't know what it means for a student to get an A or a B or a C. We don't know what it means for them to get a distinction or a high distinction in terms of what they know and can do. We need you to say what level they're at in terms of a description of increasing competence so that I can match them to the opportunities that I have in my organisation. So we see lots of curricula trying to address what does it look like when you're just starting to be able to do these things? What does it look like when you're a bit better and a bit better and a bit better? And this is proving to be a real challenge for curriculum writers because we haven't had to think that way in the past. We don't have years and years and years of history and experience to draw on. Thankfully, there's some new tools that are being designed and developed by researchers that sit alongside this work and can be very helpful in informing these decisions. The biggest tool in the STEM area in the science community call them learning progressions and the mathematics community call them learning trajectories. But those learning progressions, I'll just use the science term, they're absolutely important for informing the decisions that curriculum makers need to make because they're evidence-based models of learning and they describe what these stages of increasing competence look like. But instead of being something that is just hypothesised, that some researchers got together and they think that this is how it goes, or some curriculum writers got together and they think that this is how it goes, they're actually evidence-based. They're empirically testable using assessment data from students. So what happens is that the stages are hypothesised, assessments are designed to assess those, gone out, administered with students, analysed, and sometimes the level descriptions get changed to better reflect what's actually happening for students. And these models, they're models, and scientists are really good at understanding models, so it's nice to be presenting to a science and maths audience. Because they're models, we know that they're not perfect. We know that they just show typicality. We know that they don't capture every single person's trajectory, but they are models and they're really useful. I'm going to show you how they can be used now, but I wanted to summarise some of the uses that come out of the literature. So the American National Research Council identified in 2007 that these were really useful for curriculum development. There's a study that I wanted to direct you to from 2009 that is one of the only opportunities for actually empirically testing whether students come out with better outcomes from a curriculum that's designed with a learning progression than they would out of the traditional curriculum. And that actually found that they do improve it. It was a study done at university level because it's obviously much easier to control such things at university. And it was done in university physics across 4 really high quality universities in the US. And they implemented a new curriculum with half of the students at each university, and they discovered that those students came out with a much better learning. They covered more, they could do more with it, they could reason better with the information that they'd gained. In 2011, there was a really important paper written about learning progressions that talked about their ability to align curriculum, pedagogy, and assessment. And we know from other studies that when those 3 are aligned, that students have better learning outcomes. So it kind of provides an explanatory theory that sits under what we were seeing in some of the other studies. And then finally, the OECD have identified them in their literature review, which was much broader than just science and maths. They identified that learning progressions can help reduce overcrowding in the curriculum. Again, all of these I've got references to at the end of the presentation. Now, I wanted to talk a little bit about my particular work and the work of the team that I work with. So I'd like to share with you how we've used some of the new assessment data to, or the new styles of assessment for some work in the Philippines. And I wanted to give you a little bit of background before I explain that what's on the screen. So about 10 years ago, the Philippines had massive curriculum change. They'd previously had a 10-year curriculum and they expanded that to a 13-year curriculum. So they added what they call kindergarten for students that were a bit younger than were traditionally at school, and they added grades 11 and 12 onto the top. As well as doing that, they very much reconfigured their curriculum, making some really big changes. In the science curriculum, they were hoping to shift not perhaps to the full-blown STEM idea, but to a smaller version of that. They wanted to shift from just knowing content to being able to apply it, and they wanted to include science skills. So the kinds of generic things that go across all of the branches of science about how you pose questions, how you create hypotheses, how you conduct experiments, how you draw conclusions from those, analyse your data, all of those sort of things. So they were bringing the two things together. What they didn't do a very good job of is balancing that reduction in content. And this is, I'm saying this based on the research that we've come up with, but also I think they would acknowledge that themselves. So what we did is we took these new ideas of learning progressions and assessments matched to learning progressions to assess whether students were ready for the curriculum of the grade that they were going into. So did they have all the prerequisite skills and knowledge that they would need to be able to engage fully in the curriculum? What we found is overwhelmingly that they didn't. So I'm showing you just the results for grade 8. We assessed the students just at the beginning of their chemistry study within grade 8 before they'd had a chance to learn anything. So they learnt the grade 7 content almost 12, or actually a little bit more than 12 months before. And then we were seeing how much had they retained, and not only how much had they retained, but what could they do with it. It was one of these assessments that was checking what you could do. We ended up with 4 levels of quality, and we've been talking about them in our presentations as basics, precursors, prerequisites, and then advanced skills or advantageous things that were above what would be absolutely necessary, but that would really help the students if they had it. Obviously, those students who were at those top 2 levels of competence, prerequisite or advanced, they were fine for dealing with the curriculum. But those who were at the basics and the precursor level, they couldn't get in. They didn't have the knowledge that allowed them to engage in the curriculum and understand what was going on. So they were being shut out. As you can see, the majority of students in regular high schools were being shut out at grade 8. And if you can look at the table that I've just displayed on the screen, so we tested students before they began chemistry component within grade 7, grade 8, grade 9 and grade 10. And we tested 2 different cohorts of students. In the second column, you can see the proportion of students who were ready, who were just from a sample of regular high schools. So these are just generic normal students within their normal high schools. And you can see what happens. Going into year 7, 39% of students had the prerequisite skills and knowledge. When it goes into year 8, it's 27, then it goes to 13, then it goes to 11. The situation gets worse and worse and worse as it goes on. We didn't include this study at grades 11 and 12. This was just focused in what they call junior high school. But you can imagine what's going on in year 11 and 12, that they're not able to deal with that either, because they're not coming in with the expected knowledge and skills that they need. Our hypothesis is that there was too much knowledge and too much content, and they couldn't master it all with the addition of this emphasis on being able to apply the content and having the science skills in there as well, that there was just too much. What was even more alarming, I think, although those data was very alarming by itself, was that we also assessed a group of students from science high schools. So these are selective schools that are designed to really collect the best and the brightest science students and to really give them every advantage. So they're better resourced, the teachers have higher qualifications, they have more time to study science than some of the other learning areas. And yet we see that they're still not really keeping up with the curriculum. So this was a real warning sign in the Philippines, and they're since undertaken to revise the curriculum, and we're working alongside them to help with that. One of the big things that we're trying to do is to reduce the amount of content in the curriculum so that people have time to learn it. Another thing that we're doing is doing a lot of work with teachers to build their formative assessment skills, because we had another research project that showed that most of the teachers didn't have the formative assessment skills that they needed, so that when students were coming into their classroom, if they didn't have what was expected, the teachers didn't have the skills to go and figure out where the students were and how to help them progress. So that was something that we're working very hard with the Philippine Department of Education to build those skills, and they're putting a lot of investment into that because they understand that it's a real area of concern. I'd like to then go on and look at a very small piece of this work, helping them inform their what they're calling an enhanced curriculum, the next iteration of their curriculum that's going to be released. This is brand new work and we haven't published it anywhere yet, and you're the first audience outside the community that I'm sharing it with. So on this graph here, each of those columns is for a different one of those tests that we had, so pre-grade 7, pre-grade 8, grade 9, grade 10, and we also conducted a post-grade 10 test as well. I'm showing you the most basic level of breakdown, and this was just, instead of having 4 steps, we just had 2. And I think it shows something really interesting. Those of you who are involved in chemistry education will be well aware that there's quite a lot of debate about whether or when we should start to introduce to students ideas about matter being made of particles. So when we first start, we introduce general ideas and we treat matter as just a lump of something. And then we can look at whether it's a solid or a liquid or a gas. We can look at whether it conducts electricity, all sorts of characteristics of those things. But then when we start to talk about atoms and molecules and compounds, that's particulate thinking. So we wanted to know for the Philippines when they should introduce this shift. In the current curriculum, the shift happens during grade 8. So their curriculum assumes that prior to grade 8, students are just thinking in macroscopic ways about matter. And then at grade 8, during grade 8, they are introduced to particulate thinking, that they understand that matter is made up of atoms and that the atoms are different types according to the number of protons in their nucleus, and they behave in different ways, and the periodic table can be useful and all of that sort of stuff. That happens in grade 8. The Philippine curriculum also assumes that by the end of grade 8, students have understood that, and from then on they're able to use both macroscopic and particulate ways of thinking depending on the context that they're in. They can choose the model to think with that best suits the context. What these results show is that that's not true. Up the vertical scale are the percentage of students. The pale blue is the students who are thinking macroscopically, and the darker blue is the students who are capable of thinking in a particulate way or have particulate understandings. What's really interesting is that a number of students are coming into grade 7 with some idea that matter is made up of particles. It's not a very sophisticated idea, but they have that conception. They didn't get it from the science class, so they're getting it from somewhere else. Community, things they're reading, listening to their elder siblings or cousins. I don't know where they're getting it from, but they're coming in able to think about matter being made of particles. Nothing much changes in grade 7 to shift that proportion, which is understandable because grade 7 is thinking about macroscopic understandings of matter. So that's not a surprise. But what's quite shocking is that by the beginning of grade 9, we've hardly changed the proportion. There's still about half the students are only capable of thinking in macroscopic ways. It gets a little bit better during grade 9 and a little bit better again during grade 10, but we still have nearly a quarter of students who leave grade 10 without being able to think in a particulate manner. And that's obviously really distressing for the teachers, for the curriculum writers, for their testing results. For example, in the last round of PISA, the Philippines participated, and in their science results, they're really not very good. And it's not really a surprise when you look at this. So from this, what we've recommended is that students have multiple opportunities over the grades to engage with this content. And that's completely consistent with that kind of stepped approach that we were talking about in the previous slides. You don't just get one shot to learn something, you get to come back and revisit it. The other thing that we've noted is that when you look at the curriculum documents, the expectations about starting to shift to particulate ways of thinking are very clear in the early parts of the document. But when you get down to the grade level information, the very detailed information about what each grade needs to learn, they're not so explicit. And we've got a hypothesis that the teachers actually engage in that that fine-grained part of the curriculum, and that they've forgotten about all of those things that were listed in the lead-in introduction sections. So when working with the Department of Education staff in the Bureau of Curriculum Development, what they've realised and what they've learnt through working through this with us is that they have to make much more explicit statements for teachers. They also can't assume that teachers have the understandings that are expected. So instead of assuming that teachers understand what's encompassed in particulate thinking, they need to be much more explicit and say things like, students need to know that all matter is made of atoms. Something as blunt as that, to make sure that they're communicating as effectively as possible with the teachers. So I'd like to conclude here and just remind you of that link. From new aspirations in the curriculum, we need new assessments, we need new standards. The standards come from the curriculum. Probably, which is something bigger than this group, we also need new ways of credentialing and recognising learning for students. So with that, I'll leave you with these resources for further reading. I'd also direct you to search for ACT-ART. Oops, sorry. Let me just get back in there. To search for the Assessment, Curriculum and Technology Research Centre if you're interested in any of the reports about this science curriculum work, I've linked to the pre-grade 10 report, which has that table that I presented, but you may like to look at the earlier papers as well, and there's general information about the study on the website. There's also information on that website about our formative assessment study as well, and all the links through to papers that have been published. There's another paper that you can link through to from the study, which was a summary of the shifting thinking in assessment and how that's useful for developing and or less developed countries. So it's published in a UNESCO publication called Learning from the Bottom, at the Bottom of the Pyramid, and that might be something useful. I haven't included that as a specific one, but if anybody's interested, I can pass it on to the team and give them that. Okay, Jen, I think I'll hand back to you and we can have some conversations and some discussion.
Thank you, Pam. That was a very clear and hugely informative presentation. I'm sure everyone has many, many questions. I know I do. So I'm now going to throw it back to our curriculum writers and ask you to take 3 minutes to brainstorm within your room 1 or 2 burning questions that you have for Pam. Your room leaders will help you with this, and each room can put forward a maximum of 2 questions, but it's likely we'll only have time to answer 1. So please choose wisely. Once you have identified your questions, could room leaders please type them into the Zoom chat so Pam can prepare. So in the interest of time, your 3 minutes starts now. I'm just going to read out. Room 4 doesn't have any questions because the presentation was very informative. Thanks, Pam. But have indicated it has made them realise that they need to return to the curriculum they have written and moderate content and competencies. So that's a great outcome. Okay, a question from room 3, Pam. Based on your Philippines case study, how do we align pedagogy, curriculum, and assessment? Great question.
That is a good question, room 3, and I think it's the one that we don't really know the answer to yet. What we've been working very hard with them to do is to help them implement evidence-based curriculum. So we're using the kinds of assessment data that I was talking with you about to really understand what students are ready for and to cater accordingly in the curriculum. We're in the process, we're in the middle of the curriculum redesign stage at the moment, and it'll be a couple of years before that's rolled out fully. So we won't know for probably another 5 years about how successful we've been. The other thing that's limiting us at the moment is that we have assessment data in a number of areas. We have it for math, for science in general and chemistry in particular, and for some of the languages. Like PNG, the Philippines is a really linguistically diverse country, and that leads to a whole lot of challenges all by itself. So we have good evidence for those learning areas and we're feeding them in, but we don't have comprehensive assessment evidence across the board. And we're hoping that their assessment team within the Department of Education can set up a different style of test that will allow them to monitor this themselves in the ongoing years. So that's a second piece of work that's sitting alongside the curriculum change. There's also, as I said, the formative assessment work, which is supporting the pedagogy of teachers, because it seems apparent that changing just one of curriculum, pedagogy and assessment is not going to work. So they've bitten off a very big program of change, and we'll see if we can make developments there. So thank you very much for that question.
Thanks. From room 2, in terms of national examination on STEM curriculum, can you share with what other countries have done and certified grade 12?
You're asking all exactly the right questions today. You're thinking about all the things that are the most important things. And in Australia, there is a lot of discussion around that at the moment. At present, each state is in charge of education, each state and territory. They run their own grade 12 or year 12 final assessments. They vary enormously depending on which state you're in. And then they're all put together statistically in statistical acrobatics is probably the best way to describe it, to make it be one number that can be used across Australia, primarily for university entrance. And there's a common recognition from everybody that that's not okay. It's not supporting students with diverse backgrounds as well as it should. It's not meeting the needs of employers. They've been incredibly vocal about that. And so there's work with this profile stuff that we're working alongside to try and figure out the answers and to try and build the evidence base and the research base on which people can make decisions. Some states are moving ahead quite quickly. So, for example, South Australia want to have learner profiles of the style that we showed today in place in 2 to 3 years, which is a pretty big aspiration. Some groups have gone it alone. So there are a group of schools called Big Picture Schools who provide an alternative approach to education in Australia. We've released the first lot of learner profiles, again, very similar in their design to the one that I showed you, with Big Picture Schools at the end of last year. So just a small pilot group of students were credentialed with learner profiles. And they've been very successful, that small group, at using those profiles both to get access to university, if that was the aim of the students, and also to get employment. So our very, very tiny test case seems to be standing in good stead. It seems to look like it's being well received. But there are lots of things that we need to still discuss, I guess. Have I covered that enough?
I think so.
Probably one thing is that an examination is not really the best way to assess all of these things. And so most of the learner profiles are using a combination of assessments that happen in other ways, more judgment-based assessments that happen over a longer period of time with examinations, or sometimes without examinations in the case of the Big Picture Schools. But it looks like whatever comes out will be a mixture of those. Something else that's really interesting in the Big Picture pilot study, and is going to be a feature, I think, in the South Australian one, at least it's looking like it at the moment, is that there'll also be input from people who are not the teachers, not the educators. So when the students go out and, for example, do work with the environmental community group, people within that group will be asked to give feedback on the student as well, and that will come into being part of the profile. That's very early work, and we're still trying to find out how to do that reliably. At the moment, a couple of assessment processes that we're using use that methodology, and we're making sure that we're constantly changing, because we don't think that it's terribly reliable information necessarily at the moment, and we're developing some new techniques that will help it be. We've got another study that's doing a similar thing, which interestingly is not with students, but with aspiring principals, because the principal selection panels in Victorian schools said that they weren't very comfortable with the information that they had to make decisions on about appointing principals. And so we've used a similar method where there's a more formal assessment process and also evidence gathered from people who've worked with these aspirant principals. And we're bringing that all together in one assessment. That's also interesting because we're learning from both of these, but we don't have any clear answers yet. It's fascinating though. We're having lots of fun.
Thanks, Sam. A question from the chemistry bio room. How do we determine the content of STEM curriculum as we progress through the grade levels?
Yeah, that's another difficult question. The good thing is that a lot of in science, and in mathematics, a lot of learning progressions and learning trajectories have been developed. And in fact, in mathematics, there was a study, I think it was Stabbard, who released in maybe 2019 an amalgamation of all of those. And so there's a great big list at the end of documents, published research that you can go to give you an idea. So in science and mathematics, we've got quite a lot of resources to draw on. The tricky bit is that they're all a bit idiosyncratic. There's not a systematic way of looking across, but you can definitely find those learning progressions and use the level descriptions in them to help you form the curriculum.
Amazing. Thank you, Pam. They're asking all the difficult questions.
I love it when they ask the difficult questions because it means that they understood what I was talking about. If they ask the easy questions, it means I didn't communicate very clearly.
Excellent. So just one last question from Kathy, rather than one of our rooms. She says, I wonder if Pam might talk about emerging changes in the Year 12 assessment in Australia towards learner profiles.
So I think I probably addressed that a little bit in the discussion about STEM earlier, but one of the real challenges in Australia is that we have each state and territory is in charge of its own Year 12 development. And what that means is that we end up with some quite fragmented approaches to things. And I think that we will find very, very different changes happening in each state. The advantage, though, for us is that some states are risk takers. They're prepared to adapt and try these things out much earlier than some of the more conservative states would be. And I think that's where the work from South Australia has come. They understand that they have a very diverse community and they want to make sure that the capabilities and competence of all of their students are recognised, whether that's from a kid who's growing up in a really remote community and maybe has lots and lots and lots of practical application strengths, but not so many, book learning content strengths, compared to somebody who's, very privileged, going to the best schools in central Adelaide. And so they want to make sure that their learner profiles are suitable for all of the students and capture that real diversity of skills and honour them appropriately. And that's where they've been really, really innovative in their approach, and we're very much enjoying our work with them.
Thanks, Pam. I know you have to head off for another presentation soon, so that's all the questions that we have time today. But once again, a huge thank you for spending the time with us. I know your PhD, you're at the final sprint of your PhD, so your time is hugely precious. Thank you for choosing to spend with us and share your extensive knowledge on assessment and STEM. We really appreciate it.
You're most welcome. And if questions arise later in today and you'd like them to be dealt with separately via paper, I'd be very happy to take those, because if you're like me, the question comes after the speaker when I've had a bit of time to really think about it and churn through the ideas. So thank you for the opportunity today. It's been a great pleasure for me. I've really appreciated it, and I'd be willing to have further contact if anybody is interested. So thank you very much, everybody.
Thanks so much, Pam. See you later.
Bye.